Okay, so we're going to try to knock out these last four in one shot because they're relatively easy. We've got pipe, square tubing, flat bar, and round bar. Now, when inserting pipe and square tubing, it's important to understand that these are not HSS shapes, which are really, really similar, but have different callouts and a little bit different sizing. I know that the AISC book has um, both the standard pipe sizes and the HSS, the hollow structural steel. But the CADWorx catalog only has pipe and square tubing. So we're going to stick with that. Within pipe, we've got standard XS and XXS sizes. And this is how they will show up in single line too. This is how they're being called out. Again, not called out like HSS. So I want to keep that in mind. Let's go with the P6. Pretty simple to insert. There's no rotation. There's no centerline location. It's always at the center, but you can choose your insertion at the ends if you want it to. Go ahead and pick 2 points. Let me stretch that out a little bit. And there's our pipe. Okay, so there's that. Conceptual. You've also got square tubing, which has a few more insertion points. It does have rotation based on where your insertion point is. It also has rotation because, unlike pipe, it doesn't have all symmetrical sizes. It does have some oddball sizes. Here's a TS 7 by 3 by quarter. And so we're going to pick points, and we'll set it to 0. And then there's long direction is floating this way. Centerline location can be set to the center. I have it at top. So there it is in the center. And then you can rotate this around that center line to be vertical. So it's kind of like wide flange in a sense that you've got these multiple insertion points, and then you've got the 3 centerline location points and your rotation. So there's your tube steel. Again, this is how it's going to be called out in single line steel. A workaround is to use a structural or like a square tubing size that's about the size you're going to need. And in your single line steel, just turn off the tag so that it doesn't show the size, and just manually put a text string in there of whatever size it is and call it out as HSS if that's what you're going for instead of pipe. So that's pretty self-explanatory. Those are kind of easy to understand. If you're building pipe handrails by hand, you can use 1.5. It's pretty common size, and you get your pipe handrail. Okay. Next, you've got our flat bar. Flat bar is good for like toe plates is a common thing you're going to see flat bar used for. You can also do square bar. I've not had a use for it, but you can do square bar. So we'll choose flat bar. Common size for flat bar, something like 4 by 1/4. Again, insertion points. This is use at your own discretion. I don't have a preference on this one. Sometimes I've gone center. Sometimes I've gone top. Same thing with the centerline location. Rotation, I leave it at 0. Actually, I think I leave it at 0. Because what happens is, on this one, it kind of follows the orientation of the diagram here. 0 is vertical, like the long dimension is vertical. So 90 degrees would be rotated flat. So you can use these plates for transition plates for grading, shim plates, filler plates. I'd use more of I'd actually use a plate tool for that. It's probably easier, but you can use flat bar whenever you need actual flat bar for whatever the reason. So this is flat bar, and then you have rods. Really simple. You can use these. Just pick your diameter, and it's like pipe kind of. Just not really much to say about it. You just put it into. You just place it, and that's it. That's all there is to it. There's no rotation, no centerline location. So, and that's those 4 knocked out.